Assalamu alaikum. Welcome to our channel Browsing Physics. In this channel we are going to solve the question papers, topical question papers from IGCSE Edexcel Physics. Today's topic will be on electricity. Okay, so let's dive into the questions. The first one says the diagram shows some lamps connected together. There are 20 lamps. There are 20 lamps. Connected in series with a 9 volt of electric supply. Okay, so the first question says what is the voltage across each lamp in the series circuit. Okay, so we know that in a series circuit usually the voltage is shared and current is same throughout the circuit. So as all of these lamps are in series connection, so the voltage must be shared within all of the lamps. So that means if 20 lamp is taking 9 volts, then one lamp should take 9 divided by 20 volts. So what is the voltage across each lamp? So the voltage the voltage across each lamp is 0.45 volt. Sorry, that should be 0.45 volt. Okay. Next question says each lamp has a power of 1.5 watt. State the equation linking power, current and voltage. So we know that P is equal to VI, which shows the equation linking the power, current and voltage. Show that the current in the circuit is about 3 ampere. Current in the circuit is about 3 ampere. So we have got the power of the lamp, power of each lamp, and we have got the voltage across each lamp in series circuit. So we can use the equation P is equal to VI, and we get 1.5 is equal to 0.45 multiplied by I. So I is equal to 1.5 divided by 0.45, which is equal to 3.3 amps. Okay, so this should be the answer, because 3.3 is closer to 3 amps. Okay. The next question says the lamps are on for 7 hours a day for 5 days. So calculate the total energy transfer during this time. So we know that we have the voltage, we have the current. So total energy transfer, if you recall the equation, that is E is equal to VIT. So we know the voltage, we know the current, and we know the time for the lamps for which it was on. Okay, so that should be here 0.45 multiplied by 3 multiplied by T is 7 hours for 5 days multiplied by, we need to convert the hours into seconds, so that should be 3600, because 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So if we multiply 60 with 60, that will give us 3600 second. Okay, so now we'll get the answer. We need to do the calculation here. So 2.45 multiplied by 3 multiplied by 7 multiplied by 5 multiplied by 3600. Okay, so we get the answer Okay, so the answer is 3402000 joules. Okay, so instead of 3 amps, you can also put the value 3.3, because according to the calculation we have got 3.3. So in that case the answer might be a bit more higher than the answer we have got here, but both of them will be accepted inshallah. Okay, moving on to the next question, which says describe the energy change that take place in the lamps when they are connected to the power supply. Okay, so we know that the lamps are getting the energy from the power supply. So here power supply contains electric energy. So we say the electric energy is transferred into here, that should be light and heat energy. Okay, so this should be the answer. Okay, so our next question says a soldering iron is a tool used when joining electronic components in a circuit. It has an electric heater. So soldering iron A operates when connected to the mains supply. So in order to make it operate, it has to be connected with the mains supply. So soldering iron A is labeled with 230 volt and 30 watt. What does 30 watt tell you about the energy transfer in the soldering iron? Okay, so we can understand that 30 watt is telling about the power of the soldering iron. So what we will write that it tells about the power rating, of a soldering iron. We can also say that we know that power is equal to energy transfer divided by time taken. So we can say that it is 30 watts, so that should be 30 joule per second. So we can also say that energy transfer by the soldering iron is 30 joules per second. Okay, so I hope you understand what does this question require to answer. Okay, the next question says this soldering iron has an earth connection. Explain how an earth connection protects the user. So we know that the earth connection will protect the user from getting an electric shock. So you can write that earth connection protects the user from getting an electric shock. This also allows the current. It also allows the current to move to the ground, as well as these allows the other protective device such as the fuse or circuit breaker to stop the faulty current flow. So it allows the faulty current or excess current, so you need to mention that, to move to the ground. Okay, so it protects the appliance, protects the user or appliance by stopping the flow of current. Okay, so writing any 2 point would be sufficient. Okay, so the next question says the soldering iron B is connected to a low voltage power supply which is 24 volts and the power rating is 70 watt. Soldering iron B is labeled 24 volts and 70 watt, which has a power rating of 70 watt. The student says, I think that both soldering irons need a 3 ampere fuse. They use the information from the soldering iron labels to evaluate the statement. So according to the student, he says that I think that both soldering irons need 3 ampere fuse. So let's calculate the current required for this particular appliance. So we know that according to the formula, that power is equal to current I multiplied by V. So from that we can calculate the required current for soldering iron B is 70 divided by 24, which is 2.92 amps, and the required current for soldering iron A is 230 divided by the voltage 30 divided by 230. That should be 30 divided by 230. Okay, so we get 30 divided by 230, which is 0.13 amps. So we can see that the student says, I think both soldering irons need 3 ampere fuse. So we can say in this case that for the soldering iron B, the current is almost closer to 3 amps. So we can say that that 3 ampere fuse would not be a good choice, or would be a poor choice for soldering iron B. On the other hand, for soldering iron A, the required current is 0.13 amps. For this case as well, 3 ampere fuse is quite larger or bigger than the required current. So we can also say that for the soldering iron A, 3 ampere fuse would not be a very good choice, or it's a poor choice for soldering iron A. So if you mention the equation, calculate the required current, and then describe why the choice of the student is not suitable for soldering iron A and B, the answer would be sufficient. Okay, so that's all for today. Next class we will solve the next year's question.